Okay, guys, today we're going to be looking at the area of two different types of shapes that we've seen before, and this is actually a really basic concept, and so it's not really anything that's too stressing for us to take a look at today. But the one thing I really want to point out right away is this area formula for parallelograms. And you should recognize that formula because it's basically the same formula that you've seen before. Perhaps you've seen it as area is length times width. And so if you remember correctly, the length times width is the area of a rectangle, whereas base times height is the same thing. Because when you look at a parallelogram, all it really is a rectangle that has been slanted over. Imagine taking your a deck of cards, and just taking the deck and just moving it over so you get this slanted look to it. And that's basically all a parallelogram is. So the area formula is exactly the same thing, except the concept of what is the base and what is the height. We look at a parallelogram, the base is this. But the height of the base is that line. So that's how we look at that shape. But, so I'm going to call this H1 and B1. And then, let me group all that together here. But now suppose that wasn't, I don't have this horizontal base. Instead, let's say I had that base. In this situation, I now have a new height to use because I have a new base, base 2, and now my new height is that height. And what is really important for you to see here is that the height is perpendicular to the base. So when we look at areas of triangles and areas of parallelograms, the one thing to remember is that the area is the base times the height, and the height is the segment that is perpendicular to the base. So going from the vertex, perpendicular to the base. So that's something that you'll see several times on the homework tomorrow, so it's just really important that you see that. When we move into triangles, it's the same exact concept. You have the base and you have the height that is perpendicular to the base. So that's really all that is. Notice that on a triangle, it's half base times height. So, a lot of times when we look at that, we go back here to our parallelogram. If I were to draw the diagonal, which cuts, I can't even draw that. Let's try that differently. If I were to draw my diagonal, what I've done is taken my parallelogram and cut it in half, and I created two triangles. So therefore the area of a triangle is 1/2 base times height. Keep in mind, guys, the height is perpendicular to the base. Okay, that's really all you need to know for that. Now, sometimes with triangles, it's a little difficult trying to find the height, especially if you're not used to looking at things in different perspectives, spinning it. So I want to make sure we very explicitly go over this and look at where this height can be. We have three options where you will find the height of a triangle. This one, as the first, you'll find it inside the triangle. In the middle, our height, remember the height has to be perpendicular to the base. So our height is on the triangle. And then the third one, notice that there's no way for me to draw a perpendicular line to that base. So what I can do is drop one on the outside. So think of it as extending the base, and now I have my new height, which is outside the triangle. Please make sure that you know and can diagram each one of these three options as to where to find the height for the triangle. It will be on the quiz tomorrow. Please make sure you know that. Again, make sure you know the formulas. Area of the triangle is 1/2 base times height, and that the area of a parallelogram is base times height. So there we go. That's all I need you guys to know for tomorrow. Thank you for taking just a few minutes of your time this afternoon to watch the videos before class starts. And I will see you guys tomorrow.